In this presentation, we will talk about Scrodinger representation. Generally, the motion of a physical system can be studied only with the help of equation of motion. If the state of a system is known at a particular time, we can say the state of previous and future. Actually, the state vector is not an observable, but the expectation value of a dynamic variable is an observable. First of all, we should know the meaning of the term observable. A quantity obtained by the process of observation is called observable. Then, if you talk about expectation value, among the so many measurements made on a single dynamical variable, most of the times you may get a particular result called expectation value or most probable value. The expectation value of an operator in general is given by expectation of A. A is an operator, is psi star, then operator A psi d tau whole divided by psi star psi d tau. If the wave function is normalized, the value of psi star psi d tau equal to 1. Therefore, expectation of the operator A equal to psi star A psi into d tau. This is the meaning for expectation. As far as our Scrodinger representation is concerned, in Scrodinger representation, the state vector psi of q comma t is time dependent, whereas the operator A suffix s is time independent. This means that the wave function psi changes with time, whereas the operator is a constant. In Scrodinger representation, state vector is time dependent. That is, psi is a function of time. With respect to time, the state vector changes. Whereas the operator, say A suffix s, is an operator in Scrodinger representation. In Scrodinger representation, operator is time independent, which means operator is a constant. Whatever be the operator, it may be a position operator, momentum operator, whatever it may be. Operator is a constant, whereas the state vector is a variable. With respect to time, the state vector is changing. Now we have to prove this statement. For that, we have to consider our Scrodinger time dependent equation. H suffix s psi s of q comma t, which is equal to I h cross dou psi s of q comma t divided by dou t. H is equal to E psi logic we have used. Hs is a Hamiltonian operator in Scrodinger representation. Psi s, this is state vector in Scrodinger representation. State vector is a function of time. Q is the position coordinate, which is equal to I h cross dou by dou t of psi s of q comma t. The state vector psi s of q comma t is obtained by operating the wave function psi s of q comma t0 with the help of an unitary transformation operator u of t comma t0. The state vector psi s of q comma t is obtained by operating the unitary transformation operator u of t comma t0 on psi s of q comma t0. Consider this is equation 1, this is equation 2. This is our unitary transformation operator. This operator satisfies the condition u of t comma t0, u dagger of t comma t0, which is equal to u dagger t comma t0 into u of t comma t0, which is equal to 1, and u of t0 comma t0 is equal to 1. See here, psi s of q comma t is a state vector in Scrodinger representation. The state vector is obtained by operating the unitary transformation operator u of t comma t0 on the wave function psi s of q comma t0. Now our aim is, we have to prove the state vector is depending on time. Now we have to evaluate the value of u of t comma t0. What should be the value of this unitary transformation operator? We have to evaluate. For that, we are introducing these conditions. This unitary transformation operator satisfies this condition. U dagger equal to u dagger u equal to 1 and u of t0 comma t0 equal to 1. With the help of these two conditions, we have to find out the value of u of t comma t0. Now substitute the value of psi s of q comma t in equation 1. You can get hs into u of t comma t0, which is equal to hs into u of t comma t0 into psi s of q comma t0. This is the value of psi s of q comma t, which is equal to I h cross dou by dou t of psi s of q comma t is once again u of t comma t0 psi s of q comma t0. Then multiply both sides by u dagger. hs into u dagger of t comma t0 into u of t comma t0 psi s of q comma t0, which is equal to I h cross dou by dou t of u dagger of t comma t0 into u of t comma t0 into psi s of q comma t0. Here u dagger u equal to 1. Therefore, we can write hs into psi s of q comma t0, which is equal to I h cross dou by dou t of u of t comma t0. This u dagger is written as u universe of t comma t0. U dagger is equal to u universe into psi s of q comma t0 is d by dou t. Psi s is a function of t0 alone, so that we may cancel this psi s on both sides. hs equal to I h cross dou by dou t of u of t comma t0 into 1 divided by this u inverse is written as u of 1 divided by u of t comma t0. See here, cancel psi s on both sides. hs equal to I h cross dou by dou t of, write down this u of t comma t0. We have changed this u dagger as u inverse, then u inverse is written as 1 divided by u of t comma t0. Now we will make our arrangement. Now the above equation is modified as hs, then bring this dou t here. Then this IH cross is brought to the left hand side as 1 divided by IH cross. If this IH cross comes here, 1 by IH cross, then I have written H's as such. Dou t is brought to the left hand side into dou t, which is equal to dou u of t comma t0 divided by u of t comma t0. Consider this is equation 3. Dou u of t comma t0 divided by u of t comma t0 is the only term available on the right hand side. Now we have to integrate this equation 3. On integrating equation 3 with respect to time, you may get 1 divided by IH cross H's into integral of dou t is t, limit varying from t0 to t. Lower limit is 0, t0, upper limit is t, which is equal to integral of this right hand side. Integral of dou u by u is log of u, because if we differentiate u of t comma t0, we can get dou u. Therefore, the integral value of this right hand side is log of t comma t0, then limit varying from t0 to t. This is 1 divided by IH cross HS into upper limit is t minus lower limit is t0, which is equal to log u of upper limit is t comma t0 minus lower limit log of u of t0 comma t0. Instead of t, we have to substitute t0, the lower limit. Then we have to further simplify. See this. This is modified as minus I divided by H cross. Multiply the numerator by I and also the denominator by I. I square is minus 1. So minus I by H cross HS into t minus t0, which is equal to log u of t comma t0. You know that u of t0 comma t0 equal to 1. Therefore, this term is 0. Log u of t0 comma t0 term is 0. Minus I by h cross hs into t minus t0 equal to log u t comma t0. We need the value of this unitary transformation operator u of t comma t0. Consider this is equation 4. If you place it power e, we can get u of t comma t0 is equal to e power minus I by h cross hs into t minus t0. This is the value of unitary transformation operator u of t comma t0. From equation 4, in order to remove the log, you have to raise this to the power e. E power minus I by h cross hs into t minus t0 equal to u of t comma t0. Now we should go to the state vector. We know the value of psi s of q comma t. Psi s of q comma t is known to you. Psi s of q comma t, which is equal to u of t comma t0 into psi s of q comma t0. From this, psi s of q comma t equal to, substitute the value of u of t comma t0. It is e power minus I by h cross hs into t minus t0. This is multiplied by psi s of q comma t0. Okay, this is equation 5. From this 5, we may conclude that the state vector in Scrodinger representation is time dependent because the time dependency is explained by this term. Therefore, we may say in Scrodinger representation, the state vectors are time dependent. This is the value of unitary transformation operator. From equation 5, it is clear that in Scrodinger representation, state vectors are time dependent. Now we have to prove the operators are time independent. The expectation value of an operator in Scrodinger representation is psi s star of q comma t as psi s of q comma t into d tau. This is the expectation value of an operator in Scrodinger representation. In terms of matrix form, we can write psi s as into psi s. The psi s is in bra space. Complex conjugate of psi s star is expressed as bra of psi s. The psi s is in Ket space. This is the expectation value of an operator in Scrodinger representation. Now, we have to prove that operators are time independent in Scrodinger representation. For that, we have to go for equation of motion. The equation of motion is given by d by dt of expectation of as, which is equal to as, sorry, this is psi s state vector, psi s as dou psi s by dou t plus dou psi s by dou t as into psi s. See here. Initially, we have kept this one as a constant. Differentiate this dou psi s by dou t. Then keep this one as a constant, and this is a variable. So dou psi s by dou t as into psi s. We should know the value of dou psi s by dou t, and then its complex conjugate value. Dou psi s by dou t in bra space is nothing but dou psi s star by dou t. Now we have to find out the values. Hs psi s equal to I cross dou psi s by dou t. Therefore, dou psi s by dou t equal to 1 by I cross Hs psi s. Actually, this is dou psi s by dou t in Ket space, which is equal to 1 by I cross Hs into Ket of psi s. So, this value is this much. This is our Scrodinger equation. Hs psi s equal to I cross dou psi s by dou t. From this, dou psi s by dou t is equal to 1 by I cross Hs psi s. This is written in Ket space. Dou psi s by dou t in Ket space equal to 1 divided by I cross Hs into the state vector in Ket space. So, the value of this one is this much. Now we have to find out the value of dou psi s by dou t in bra space. This value we have to evaluate. For that, find out the complex conjugate of this equation. Dou psi s star by dou t, which is equal to minus 1 divided by IH cross. In the case of complex conjugate, we have to change the sign of phi. Here, plus IH cross is present. We have to change that one as minus IH cross. Therefore, minus 1 divided by IH cross into HS star psi S star. Here, HS is Hermitian in nature. Therefore, this is modified as minus 1 divided by IH cross psi S star into HS because of its Hermitian nature. HS star psi S star equal to psi S star into HS because HS is Hermitian. This is our dou psi S star by dou t is graph dou psi S by dou t because the complex conjugate of the wave function is present in the graph space. Dou psi S star by dou t is our graph dou psi S by dou t, which is equal to minus 1 divided by IH cross, then HS into graph psi S. So that instead of this, we have to write this. Just put up all these values. This is equal to psi S, then EAS. Instead of dou psi S by dou t, we have to write this. 1 by IH cross is a constant, take it out. 1 divided by IH cross. Then dou psi S by dou t is HS psi S. So this is HS, psi S is in graph space. Instead of this dou psi S by dou t, we have to substitute 1 divided by IH cross. Already this IS is present, written as such AS into this HS, the state vector in H space psi S. Now come to this part. Plus graph dou psi S by dou t is minus 1 divided by IH cross. So right now minus 1 divided by IH cross. Then this should come first. Graph space of psi S. Graph space of psi S. And here AS is present, but here the term HS is present. So HS AS into this psi S. See here, to understand more, write down this for your convenience. HS into graph psi S. Now you may get clear picture. See here, instead of this dou psi S by dou t, put this minus 1 divided by IH cross, minus 1 divided by IH cross. Then write down this graph psi S. Then HS, then AS, HS, AS into this get space of psi S. Now we have to combine all the terms. See, d by dt of expectation of AS equal to 1 divided by IH cross. Take this as a common term. Psi S AS HS minus this term HS AS into this term psi S. See this psi S, this psi S, psi S in broad space, psi S in ket space are taken as a common term. 1 by IH cross is commonly present, take it out. Then combine these two terms. AS HS minus HS AS. This is equal to 1 divided by IH cross psi s in brass space. Then inside the square bracket we have to write AS comma HS. Then psi s in get space. This is IH cross d by dt of AS, which is equal to psi s in brass space AS comma HS inside the square bracket. The meaning of writing the operators in the square bracket is equal to AS HS minus HS AS. This is the meaning. So this is presented in this form, AS comma HS. Any operator that converts with the Hamiltonian becomes constant of motion. If AS converts with HS, then the value of IH cross d by dt of expectation of AS equal to 0. Any operator that commutes with the Hamiltonian becomes constant of motion. If AS HS equal to HS AS, AS comma HS equal to 0, because AS comma HS inside the square bracket is equal to AS HS minus HS AS. Suppose AS and HS are commuting with each other, then the value of AS comma HS inside the square bracket is equal to 0. Any operator, whatever be the operator, it may be a position operator, momentum operator, energy operator, whatever it may be. If the operator commutes with the Hamiltonian, that becomes constant of motion. So that if AS commutes the HS, the quantity IH cross d by dt of expectation of AS equal to 0. From this equation, we point out that AS equal to constant. The operator in Scrodinger representation is a constant, because if you differentiate a constant, the value is 0. d by dx of x equal to 1, but d by dx of a constant 1 equal to 0. Therefore, if the operator AS commutes with HS, the right hand side is equal to 0, then we can say IH cross d by dt of expectation of AS equal to 0. This means that AS is a constant. AS is independent of time. Therefore, we may conclude that in Schrödinger representation, state vectors are time dependent, but operators are time independent.